Hello everybody. This is a little bit of a different video for you. There's a bad meme on the background, of course, in case you've been missing those things from your classroom. Today we are going to do comparing simple interest and compound interest using technology. So first of all, there's two parts to this process. Firstly, we need to calculate values of a situation using simple and compound interest. Our normal simple and compound interest formulas are shown on the screen. Hopefully you do remember them from our past adventures. We are going to use them to generate a table, and I'm going to show that table in Microsoft Word, but it could be written down by hand or made in Excel, doesn't really matter. So after we've made our tables, we're then going to put them in Excel and make the graphs in Excel. So we won't be doing the graphs today by hand. We will be using technology in the form of Microsoft Excel. So to start off with, we're going to start with a task similar to what we have done in previous lessons. We're going to decide on a certain amount of money and what's the name? We're going that. Rachel can be the name for today. Invests $8,000 at I'll just call it 3% interest. All right. Now, I haven't specified simple interest or compound interest because I'm actually going to follow this situation using simple interest and follow it using compound interest separately. And we're going to follow it for 5 years. You can see my table there. See our table? I'm going to follow it for the first 5 years. Year 0 is the starting value. So there we go, $8,000 to start with. And in each case for these formulas, you see the different variables there. What have we got? 8,000 is P, so I'm going to write P is 8,000. I have I, which is the same, lowercase I, which is the same as R, which is 3%, which is 3 over 100. So I might make that into a formula. There we go, that looks a bit better. So I in the simple interest formula, little I there, is the same as R here, and 3%, remember it has to be a decimal in the formula, so the decimal value for I or R, it's 3 over 100. You could also write that as 0.03 if you want. All right, that just leaves N, which is a number of time units, and well, that actually changes depending on which value we're looking at. It could be 1, 2, 3, 4, or 5, and I'll make that look beautiful as well. The Microsoft equation editor isn't really that bad, is it? When you look at it. Okay, so in the case of our simple interest calculations, to find out how much Rachel's $8,000 investment will be worth at any moment in time, I'm going to put the values in the formula. So it's going to be 8,000 times, there we go, 8,000 times 3 over 100 times N, where N could be 1, 2, 3, 4, or 5. That makes it easier to do in the calculator, because what I'm going to do now is I'm just going to type that in. I'm going to go 8 times 3 over, well, here I'll do it as a fraction so you can see it all fully. 3 over 100 times, for the first year, N is 1. Now that actually, we have to be careful with this because that is going to give us the interest, which we then need to add on. Ooh, why did I change it to 8? I wanted 8,000. There we go. So there'll be $240 interest to the first year. If you add $240, you get 8,240, right? The interest is 240. Add that to what you started with. Your investment will be worth 8,240. Now, you know what? If you look back to our recurrence thing, you're going to work out that it's going to go up by $240 each year. So But that's all right. Look, after 2 years, we do the same simple interest with n being 2, you'll get 480. So compared to the original amount, after 2 years, you would have got 8,480. You've got a total of $480 interest. After 3 years, just changing the n to 3, you will have got a total of $720 interest by that time. Right? So I'll just note here, add the interest amount to the principal to get the total value at any moment in time. Right, same thing again back on the calculator. Notice how I just click back here to change it each time. Makes it really quick. At this point, we've got a total, it will be 8,960 at this point. Go backwards again, change it to 5. 5 years, you would have got a total of $1,200 in interest. So that's 9,200 is the value of your investment. The value of your investment any time is the amount you put in plus the interest you've earned. Remember that. For compound interest, this thing's slightly easier. So because A, it gives you the value. A is the value of your investment, and it just gives you that at any time from the formula. We put in our 8,000 for P. We put in our R, which is 3 on 100. And N there, of course, will be different depending on which year we're looking at. So over at my calculator now, I go my 8,000 times, open bracket, 1 plus, I'll do the 0.03 for those of you who've done it that way. It doesn't matter whether I put 3 over 100 as per the formula or I put 0.03, it's the same thing. The first year N is 1, so after the first year we'll get the same amount as in simple interest. That always happens for the first time unit. Simple and compound are the same. I go back and change that to a 2. After 2 years, it will be worth 8,487.20. I go back. After 3 years, I've got 8,741.82 cents. After 4 years, $9,004.07. After 5 years, I got $9,274.19. You'll notice over time that you do indeed earn more money with compound interest. So if you're investing money, you want it compounding rather than simple, because you'll tend to make more money that way. And there we go. That's how we generate a table. And the joy now, and I may actually have to get rid of my spaces in here for it to copy properly. That may seem like a very minor thing, but we're going to put this in Excel now. And this will allow us to directly compare the simple and compound interest for Rachel's situation of an $8,000 investment at 3%. To do that quickly, by the way, I highlighted the stuff here. I did Control C. You also could have right-clicked and gone copy. That also would have done the same thing. Then over in Excel, I pressed Control V for paste. You also could have right-clicked and you see you can paste stuff. Anyway, the important thing is I've now moved our table we have made over into Excel. Hopefully Excel's reading it as a number. If it isn't, it's all going to hurt for us. So there we go. Now I highlight the data. I go Insert, and I'm going to do a line graph. Where's one that looks like a line here? That looks kind of like a line, doesn't it? What the heck's it doing with year though? Why has it done that? I'm going to try and fix that quickly. Instead of making year the x-axis, it's made it a variable, which is just wrong. So the horizontal axis should have been that. That's a bit better. And select data, year shouldn't be showing as data. That's a lot better. Now from there, you'll realize that Yeah, this is Rachel's $8,000 investment. And you will see that as the year goes on, of course, there are a couple of things missing here that I don't like. Hopefully you realize by now what I don't like. It's missing a couple of things. It's missing axis labels. We need an axis label there, which is year. We need an axis label over here, which is future value in dollars. And there we go. Now the compound interest should be slightly higher than the simple interest as time goes on, and that's correct. The future value there is going up, more for the compound interest. Now I'm just going to quickly check, does that somewhat answer the sort of stuff we're meant to be able to do? We're meant to be able to make tables, we're meant to be able to draw graphs. You know, if I wanted to look at that closer up, I could change this axis. I could format the axis. See how I right click there and said format axis. I could look at it a bit closer up if I set that to be, you know, 8,000, which is what it started on. You can see the effect of the compound interest rising a bit faster doing it this way. But there you go. That's the sort of thing. I should have put an apostrophe in there, shouldn't I? Because it belongs to Rachel. Some sort of English quirk, don't ask me. And there we go. So you need to be able to create these tables using different interest rates, different numbers of years. You need to be able to create graphs from it. It's okay to just create them in Excel, but you need to be able to create them in Excel. I'm now going to briefly do a small amount of extension stuff. That is the stuff that tricks people up the most, and that is when we have different compounding periods. So in this one, interest was compounding every year. We call it annually, but interest isn't necessarily compounding annually. It can be anything. It can be twice a year, which we call biannually. It can be quarterly, so 4 times a year. It can be monthly, so 12 times a year. It can be fortnightly, which is 26 times a year. It can be weekly, which is 52 times a year. And it can be daily, which is 365 times a year. As an example, just so hopefully you get a little bit more comfortable in this, I'm going to do one where we are comparing annually, quarterly, and weekly. The annual values we already have here, so I'm going to drop them in. I'm going to continue this to be our Rachel's investment. It's just going to be compounding differently. So in the case of annually, the formula looked like that. All right, but the other two I've decided to demonstrate are quarterly and weekly. Now quarterly, if you remember our compound interest formula to start with, so let's start back to the compound interest formula. That there is the compound interest formula. This is what happened when we were doing annually. I'm now going to move over a bit here. For quarterly, the interest rate needs to be per quarter. So you also need to divide by 4 to make the interest rate for 1 quarter rather than the whole year. And in turn, up here, N now needs to, instead of being number of years, has to be number of quarters. The quick way of doing that would be to multiply however many years you have by 4. Weekly, it's going to be a similar pattern. All right? In the case of weekly, I'll be here in I've got 5 minutes. 5 minutes. In the case of weekly, we divide the interest rate by 52 because we want the interest rate to be just for 1 week. While here, the number of weeks, we want the time periods have to be number of weeks, so we can multiply the year by 52 to get the number of time periods. So they're all going to start at the same amount. In fact, I might note this. In 1 year, how many time periods would there be? 4, right? In 1 year, you multiply the 1 by 4, there'll be 4 quarters in 1 year. 2, we multiply it by 4, there'll be 8 quarters in 2 years. Multiply 3, there'll be 12 time periods. I'm just going to call it n still. We've just got to be careful. N remains number of time periods. In 4 years, there will be 16 quarters. In 5 years, there will be 20 quarters. Right? It's simply multiplying it by 4 each time. The number of weeks for each year will be different though. N, we have to multiply the number of years by 52 because there's 52 weeks in a year. For 1 year, that's simple. For 2 years, you may wish to put it in a calculator. So 2 years, 52 weeks each year, there's going to be 104. N will be 104. If you multiply 52 by 3, you'll get 156, 208, 260. Now, again, I was just multiplying the years by 52 there. You can do it in a calculator, that's fine. You don't have to be weird like me. All right, so now in each case, to work out the actual value, let's drop it in the formula. I'm going to write that formula, 8,000 times 1 plus fraction 3 over 4 times 100 to the power of, the first one there was 4. Right, so I'm using that formula with n is 4 because that's what you'll have after 1 year. And I get $8,242.71. I'm now going to use that trick again where I'm just pressing back on the calculator and changing the value of n. So at 2 years, when n is 8, 492.79. When n is 12, 8,750.46. When n is 16, we're going to get 9,015.94. When n is 20, we're going to get 9,289.47. Now, the more frequently you compound your interest, the bigger value you should get. So all of them should be just slightly bigger than what they were for the annual numbers. Ah, there's something wrong there. Did I copy that number down wrong? So when n was 12, 8,750.46, or did I do the original one wrong? See that one there, that there should be slightly more than the one there. Maybe I made an error in my original numbers. Has anyone picked that up? I'm going to try that quickly. If you look at the history here, no, it's not going to let me do it. It doesn't go back that far. 8,000 times 1.03 to the power of 3. Whoops. Look, see? I just realized my own error. That was 41 rather than 51 in there. Better fix that. Did anyone realize that as we were doing the video? Now notice how I picked that up. The logic that if you're compounding quarterly, the value should be higher than the values if you're compounding annually. And so I realized that number here should have been bigger than this number here. And so I found my own error. Isn't that fun? See, you apply logic to these things, you can come out with all sorts of cool things. Anyway, for the bottom row now, I'm now going to use a calculator to find these values. So it's this formula here, and we've worked out the value of n, the number of weeks at any given time for any number of years. We've got the n values there. So we're dividing by 52 now. And we also need